So now we are going to start our study of motion, and we're going to begin with the study of kinematics. Kinematics is a fancy way of saying that we are going to focus on observing on how motion works, and we're going to wait and try and understand the causes of motion in a future unit. So we want to carefully observe motion, and if we're going to observe it quantitatively, we're going to have to learn some tools to understand how motion works. So when looking at motion, there are two types of values that we're going to want to keep track of. One type of value is called a scalar. A scalar is a number that is a magnitude and it does not have a direction to it. So an example of a scalar is a weight. A brick weighs 3 kilograms, so that's an example of a scalar, right? It's not, there's no direction associated with it. Temperature, time, and speed are additional examples of scalar values. There is an amount, so a number of degrees Fahrenheit, a number of seconds, or a number of pounds, or a speed in miles per hour. Notice all of these scalars can have units, but they are numbers that have no direction associated with them. In contrast, if we are trying to understand motion, we may want to describe some values as vectors. Vector includes both the direction and an amount. So we're going to be looking at vector quantities such as velocity. So velocity has both a magnitude and a direction. If you are driving 50 miles per hour to the east, that is a different vector than if you were driving 50 miles per hour to the north. Now I just said that speed was a scalar, and this is the difference between speed and velocity. So that is that speed is defined only by how fast you are going, while velocity is not just the speed, the 50 miles per hour, but it also has to include the direction that you are going. So without that, you do not know the velocity. So in a physics class, speed and velocity have different meanings. Speed is a magnitude, it's sort of the reading on the speedometer, and the direction doesn't matter, while velocity requires both the speed and the direction. So you need the compass reading as well as the reading on the speedometer to know the velocity. To try and keep things clear, we put arrows on top of the symbols, so V with an arrow on top clarifies that this is a velocity vector. So there are a lot of different vectors that we're going to use. A few are listed here, including force. So if you push something, both how hard you push and the direction that you push is required to define a force. Torque is sort of the analog of force where you're turning something, so there the direction matters. And then also things like acceleration, so the direction that you are accelerating something is critical for defining the acceleration. So for the moment, we're going to focus on one-dimensional motion, where our object is moving left or right, or up and down only, so we don't have to worry about angles yet, but we will get there pretty soon. So a good example of demonstrating the difference between scalars and vectors is the difference between distance and displacement. So distance is a scalar quantity, and that is the total distance traveled, and displacement is a vector, and it tells us the change in the position. So the change in the position is by how much you have moved. So to find that, the displacement is the final position minus the initial position. So if you run a lap on a track and you return back to the starting line, the distance traveled is 400 meters. However, your displacement is 0 because you are exactly where you started. In our example here, we leave the MCalc building and walk 2 kilometers east to Carytown, then 2 kilometers south to Forest Hill, and then 1 kilometer back across the Lee Bridge to MCalc. So in this example, the displacement is 0, since we started at MCalc and we ended at MCalc. The distance traveled here is 5 kilometers, because that's how far we walked. Sometimes we will simplify our equation and use the displacement to be x minus x naught, or x sub 0. So this x subscript 0 is shorthand for the position when we started observing the motion. That means the displacement is our current position minus our original position. So in this example, we have a car that is moving to the right, and our initial position here, x0, and the final position here is x final. That means the displacement is to the right and is equal to the distance. The change in time is the time difference when the car is at its initial position and when it's at its final position. So in our example here, the car has moved to the right by a certain amount. in a certain amount of time. One thing I'd like to mention here is that a displacement to the right is by convention a positive displacement, and a displacement to the left is a negative displacement. So one preconception that can cause a lot of trouble when first learning about motion is that a number is not only a amount of something. In fact, in many cases, numbers are better thought of as defining a position on a graph or a position in space. That means if an object has moved to the right, the displacement has a larger value, and if the object moves to the left, then the displacement has a smaller value. This can mess with our intuition, because if I move to the right by 5 meters, my position increases by a value of 5 meters, and if I move to the left, my position decreases by 5 meters. But it's not really a matter of more or less, right? It's a matter of direction. So to try and keep that in the back of your mind, positive and negative are not an issue of more or less, but a matter of direction. So right or left, or up and down. So in our example here, our car has traveled a certain displacement in a certain amount of time. So, and we call that a displacement divided by time, the velocity. So average velocity is defined by the displacement traveled divided by the time taken. So the formula is delta x, the change in position, divided by the delta t, the change in time. So the triangles here, they are the Greek letter delta, and basically that means the change in x, so the change in position, divided by the change in time, delta t. So our units for this, the units for displacement is meters, and the unit for time is seconds, so the units on velocity is meters per second. So our speed and velocity will be measured in units of meters per second. We're talking about average velocity right now because we don't know how fast we are traveling at any one point in time, just the average velocity over the entire time. So if I drive 120 miles to the east in 2 hours, then my average velocity is the 120 miles to the east divided by 2 hours, so it is 60 miles per hour to the east. So you could do that by driving 60 miles per hour the whole time, but you could also do that by driving 100 miles in the first hour and 20 miles in the second, or you could stop for lunch for a bit. But no matter what, if you travel 120 miles in 2 hours, then the average is 120 miles per hour, but the instantaneous velocity, the velocity at any one time, it might be different. So, if your velocity has changed over time, then that is what we call acceleration. So the average acceleration of a time is equal to the change in velocity divided by the time between the first velocity and the last velocity. So acceleration is the change in velocity per unit time. That means that the units for acceleration is the units for velocity, meters per second, divided by seconds, so the units for acceleration is meters per second squared. So that means if you were traveling very fast, but maintaining the same velocity, your acceleration is 0. Okay, so you have a few questions to answer about displacement and average velocity. So one set checks to see if you understand the difference between distance traveled versus displacement, and the other is a check on average velocity. Alright, so if you haven't already, please check to see what time your lab is scheduled. I'd like to remind you again that the labs are in person, unless you're in section 081 or 981. The labs don't start until next week, the week of August 30th, but you should double check now to make sure that you know when your lab is scheduled. Alright, so that's it for our first set of classes. So finish up your questions. Those are due on Wednesday morning at 10 a.m. Then the next set should be posted on Wednesday, and those will be due on Friday morning at 10 a.m. All right, so welcome to a new semester of physics, and good luck and take care of yourselves.